Hello, everyone. I'm just going to wait about a minute to have everyone join the room, and then we'll get started.
Oh, I thought it was just the four of us. You know, it's funny. I'm obviously familiar with San Francisco, but I didn't know exactly where the University of San Francisco was. And then when I looked it up, it was like 3 or 4 blocks where two of my brothers used to live.
Oh, really?
Yeah, we must have walked by it. But I'm one of those nervous kind of people that feel like if I don't, work there or go to school there, I shouldn't wander around. So
Ah,
never occurred to me to. And maybe that's a good thing, but yeah, I never did walk around the campus, but it was right there.
well,
It's a
you're
beautiful
welcome to come and
location.
have a look around. It is a beautiful location and right near Golden Gate Park. So,
Well, I've got a
lots of
whole
things to see.
queue of people to visit, starting fairly soon. The people that have invited us to, well, like one that is exciting, the Museum of Natural History
Hmm.
in New York City. My wife has been editing some archaeological videos of sort of famous archaeologists just to record their story, so to speak. It's not for television or anything, it's just archiving. But she now knows like the curator at the museum and has offered to give us a private tour and,
Oh, nice.
just lots and lots of people. In fact, the pandemic, I've been meeting a lot more people than normally. It's
Well,
like
good
I
afternoon.
normally travel. Well, actually, where you guys are located, I might consider going there physically to give a talk. But most places I just.
Yay!
Yeah, we'd like that. Well, good afternoon, everyone, and welcome to the University of San Francisco's MSDS seminar series in data science. My name is Sean Butcher, and I'm the Partnership Director for the Data Institute. This seminar series is brought to you by the University of San Francisco's Masters in Data Science program and sponsored by USF's Data Institute. Each year, we partner with companies and organizations around the San Francisco Bay Area and beyond to provide 9-month internships for our students. During their degree, our master's students spend 15 hours a week working at a company to tackle their data science and analytics problems. We're beginning to plan our internships for this fall, so if your organization is interested in supporting the Data Institute or working with our students, please contact us by email at datainstitute@usfca.edu. Alternatively, you can visit us at the web on www.usfca.edu/data-institute. Today, I'm pleased to welcome Brad Carvey. Brad is a senior research engineer at Sandia National Laboratories, and he's also a Prime Time Emmy Award winner for outstanding achievement in engineering for the development of the video toaster. And today he will be talking to us about impactful visualizations. We'll leave some time at the end of the talk for your questions and also try to answer some of your questions during the talk. If you have questions, please enter them in using the Q&A button at the bottom of the screen. Don't use the messaging section. Please use the Q&A button. Welcome, Brad.
Hi. I'm still getting used to after a year of talking to people that are invisible to me. I may never get used to that. I actually do really well in front of an audience, so you'll have to pretend that I'm actually in front of you. I get very animated. I'm going to attempt to share a screen. And okay, so I'm thinking maybe you're seeing something.
Yes, we are.
Okay, so I'm going to talk a bit about my background. The thing that's maybe interesting about me is that I started out as an electrical engineer, and my first job out of school was at Lockheed in the Bay Area, working on microprocessors, which were brand new at the time. I worked in Space Systems Division and did some really fun things. We had the Hubble telescope was like 50 feet away from my cubicle in a high bay in the back, and I worked on stuff for that and lots of other stuff that went into space. But at some point, I got really lucky and I got involved in an invention that kind of changed the world. It's called the video toaster, and it's the invention that allowed all those channels besides ABC, NBC, and CBS to exist. And in 1992, I got an Emmy. So we'll talk about that. But I'm going to start by this short little video. So a little overly dramatic, but it makes a point about trying to be impactful. And also the music in there was written by my brother Scott, so I like to throw that in. The nice thing about impactful visualizations is that it's really a broad term, and it's one that Chris Garazzi, who's a scientist at Sandia Labs, and I came up with to explain a wide variety of different types of ways of visualizing scientific data. And in this particular slide, I'm showing 3 images of the same data. So this is actually a real near-Earth asteroid called Galevka. I think it was a few years ago it came near us. It came close enough that it was between us and Jupiter, I believe. But there was a scientist at Sandia Labs who was curious about what would happen if you blew up an asteroid. And a lot of you probably have heard about this. Well, if you blow up an asteroid, instead of the asteroid hitting us, all the pieces hit us, it doesn't do us any good at all. But he was the guy that originally simulated that. And the picture on the left is an image of that Galevka, the actual Galevka asteroid, with an explosion at the centroid exploding. And the one in the middle is an animated version I created. And then the one on the right is a more visual version. And so that's really what I'm going to be talking about most of the time, is this idea of taking scientific data and creating more impactful visualizations. And I'll show you some examples. And this is another example of what I like to think of as like what the scientist sees as valuable versus what maybe human beings see as valuable or interesting. So there was a meteor that exploded over Siberia maybe 4 years ago. And Mark Boslow, again, this is another, the same physicist, the other one, he immediately went out to Siberia and he collected all this data, and then he simulated that asteroid entering the Earth's atmosphere and blowing up. And that image on the left is his visualization of this asteroid exploding. And I look at that visualization and it doesn't say anything to me, but to a subject matter expert like Mark Boslow, that's all he needs. He doesn't need to see anything else. And so I show 2 other versions of the exact same data, the same time step, and I'll talk a little bit more about that as well. And then the same exact data, I did a cover for Nature, and you can see that in the Nature cover, it looks more like what it looked like in real life. And in fact, there's a funny story about that particular background image. So I was creating a completely digital cover for Nature. Everything was digital. And then they found out that Science Magazine was going to do a competing article on Chelyabinsk. And so they told me instead of having 9 days to finish the cover, I had 2 days. So I immediately went online and found this image of Siberia at about the right time of day in the right location. And I sent an email to Olga Kruglova in Moscow asking her if I could use her photograph. And she must have been 12:30 at night, her time. She answered immediately and said I could. So I ended up sending her a few copies of this, and she put the image on her Facebook page saying that it was a photograph she had taken of the asteroid. So kind of fun. And so, you know, as I said, I'm from the Bay Area, and I won a Prime Time Emmy. Normally, Emmys for technical stuff are plaques, and they don't look like the statue. So Prime Time Emmy is a big deal. And I got it in 1992, the same year that my brother Dana got an Emmy for doing impersonations and stuff, Saturday Night Live. And he was nice enough in Wayne's World, which is actually a character based on me, to wear the logo of the video toaster in the movie. So that was a really fun thing. And I remember seeing on the front page of New York Times, amazing feat of nepotism, because Dana wore the logo in the movie. I also received an Addy Award. So essentially what happened is I helped invent this technology, and then suddenly I was retired, getting a lot of royalties. And I come from this incredibly creative family, and I was able to use that creativity, which was less than them, but more than typical, to use the invention for doing visual effects. In fact, I created what was probably the world's first boutique visual effects studio in Albuquerque, New Mexico. And we did a bunch of stuff. We did the opening to Men in Black. I won an Addy for a commercial with a bunch of characters, like a skateboarding apple, you know, things like that. That's what I won the Addy for. The commercial in the upper left-hand corner was always one that I really liked because it was so unusual. It was for a Japanese commercial for a cup of noodles, and they had apparently a famous rock star playing a guitar and singing, and then he jumps out of a tower and he flies into the cobblestone road and comes out as a whale. So that's the picture of the whale. It was a really artistic, cool looking commercial. And then this other shot shows a shot from a movie that I was visual effects supervisor on, and also my wife and I did the visual effects for. And this is just showing a guy with one arm, but he actually has two. And so I had a green sleeve added to the t-shirt, removed the sleeve, and then added this digital sleeve to his arm. And the thing that made that particular shot difficult was that whenever the kid's hair moved in front of it, it was hard to key it. And so I kept telling him, don't have the kid get in front of his sleeve, but that didn't work so well. And so here's a real treat for you. This has been only shown a few times. It's the opening to Men in Black with the original music.
Hey, Brad, we're not hearing the audio. Apparently, when you click, you need to click on your share screen and click at the bottom left corner of the share selection window where it says share sound.
Oh boy. There's five, or there's six. Which one is it? I can't read it from here.
It should be, go ahead, Dana.
You need to unshare your screen and then reshare, and then there's a pop-up which window that you're gonna choose, and then at the bottom left corner there's a text saying share sound that will do the magic. Yeah,
the problem I'm having is I'm sharing on a TV monitor that is hiding the edges. That was kind of a fatal flaw here. Okay, so I'm going to share a screen. I'm going to pick the screen that is on, and then, oh, share sound. I get it. And okay, so the audio is critical, so hopefully you hear it.
Yes.
They're flying high over that old rainbow. I wonder why, Lord, can't I? Somewhere over the rainbow, we're high. You know there's a land old Jerry dreamed of, once in a lullaby. Someday I'll reach upon a star, wake up with the clouds fall behind me. Where kisses are melting.
So I just want to make a few comments because this is kind of fun. And like I said, maybe only 10 people have ever seen this. And now we have more than 4 people apparently. So that would more than double the number of people that have seen it. We choreographed this animation to that music, to that soundtrack. But the movie started getting some buzz before it was released, and they hadn't locked down the rights to the Jerry Lewis song. And when they asked for the rights, normally you'd spend thousands of dollars, maybe $10,000, but they wanted $160,000. So the production said, okay, no way. And they had Danny Elfman, who had written all the music for the movie, to actually create the music after the fact. And that is very hard to do because normally you're animating to music, you're not writing music to match an animation. And there's a few other things that are in this soundtrack, the original, that are kind of fun. One is that you'll notice that at some point, and I'll play again in a second, that there'll be a truck heading towards the bug, towards the dragonfly. And in the movie, the released movie, this isn't the case, but the driver honks. And I always thought that was so weird, that why would a driver honk at a dragonfly? And also when he flies over the top of the truck, there was nothing there. So we had to create some transitional way for it to get from over the truck to this totally new scene. And so we created the illusion that it was flying through some concrete tubes in the back of the truck. So when you watch that sequence, you'll hear the truck driver honk, and then you'll see it fly up, and then it'll go through these tubes, which makes no sense. And also the dragonfly flying in front of the moon was actually a difficult shot, and it was a ode to E.T. Spielberg.
Like lemon drops, way above the chimney tops, that's where you'll find me. Somewhere over the rainbow, bluebirds fly. They're flying high over the rainbow. I wonder why can't I?
The trees by the side of the road were actually just put along the side. There's no vegetation outside of just the ones that are lining the road. Well, that's an actual road as opposed to the beginning where it was a small miniature set. Then one last thing which is fun is that we have a trick in visual effects where the director will not like a shot you did that you think is pretty good. And in this case, he didn't like the dragonfly eyes that we made look real. They were more like dragonfly eyes would look. And he gave us this direction: make them more handsome. So I don't know exactly how you do that, but we made them really stupid and cartoony, which is what you're seeing on the screen right now. And he loved them. And we thought he would say, no, those are horrible. And then we would send him the original shot and he'd say, okay, this is good. So we ended up with these really horrible cartoony eyes. Okay, so I'm going to speed through this impactful part, but I've been having a lot of trouble defining this idea of an impactful visualization. And in the industry, you have sort of the scientific stuff, which they actually call presentation graphics. And then you have the cinematic stuff, the cinematic visualizations, which are more like movie type stuff. And I'm trying to say that the impact, whether it's to this audience or to a group of subject matter experts, scientists, or whether it's to the general public, impact is the same thing. You want something that's going to have an effect on people. And then when you think about visualization, I think about, well, what does visualization do? It helps a person see something. You basically want them to see something, and you want them to be impacted by it. So you want to create something that will be targeted at a particular audience, and it will impact them, and they'll remember it because of that. And so typical scientists, this is a Mark Boslow thing again, they generate lots and lots of data, terabytes of data, and then they visualize it, and they visualize it like with that picture that I showed you previously, where Mark Boslow looks at that, and he's like, oh, interesting. And most of us are not impacted by that. And so then this is the exact same data. The one is Paraview, which is a very commonly used program. It's free. I think it's open source, but it's freely available. And it's showing velocity of Mark Boslow's explosion. And you can see based on the color, the colors more towards the warm colors like red and yellow. Things are moving faster, and the cooler colors towards blue are moving slower. And then I took that same data and I created something that looked more photoreal, but using real science. So the illumination, the density of the material, all that stuff is based on the data rather than a purely cinematic artistic thing. And this is the Chelyabinsk thing, again, showing more of a Mark Boslow image on the left, which would be a video, and then my interpretation. And the interesting thing about this Chelyabinsk meteor is that when Mark simulated it, there was a pressure wave at the back of the asteroid that it basically turns to plasma. It's going through the atmosphere. It doesn't glow red hot. It actually changes to plasma. And there's a pressure wave that forms at the back, and that pressure wave then forces plasma out the front of the asteroid. And what you're seeing in this middle picture is the air density and then the temperature of the solid material, or the melted material. And he kept telling me that I had it backwards and this and that. And he doesn't believe it's real, but we don't really know, because he did this simulation, and maybe asteroids, when they're going through the atmosphere, are actually spitting out molten material out in front of it. And that's what the simulation shows. He didn't think so. And then that's the nature cover that I did. So I can do this stuff now. It took me a while to learn how to do it. And I use commercial software. I've used Maya and Modo and Lightwave, and I settled on Houdini, and I'll talk about that a little more. But what I really wanted to do is, okay, I can do this. Can I get scientists to do that? And Chris Garazzi is a scientist at Sandia Labs, and using some techniques that I developed, he has been able to do this. And it's such a thrill to me when I can get a scientist to use tools that I create to create these impactful visualizations, because he can already do the visualization that I was showing before, the Paraview one and the spy plot one, which was the black and white one. But there are times when having this kind of an animation is more interesting to his intended audience. And so it's a thrill when I can do that. And so the way that I go about doing that is I use Houdini. Like I said, I've used lots and lots of programs. I used Lightwave back in the late 80s and early 90s up through about 98. And then I experimented with other programs and settled in on Houdini. And if you're interested in 3D animation and you've never done anything at Blender, which is a program I don't use, is free and it's really good. So that's a good place to start. If you're going to only use one program or learn one program and you want to do it professionally, Maya, I think, is probably the best. But Houdini allows me to do things that none of those other programs can do. For instance, if you see a movie where they blow up New York City, they're probably using Houdini because it can deal with really large data sets. I frequently work with stuff that has billions and billions and billions of polygons, and Houdini handles it easily, and other programs seem to struggle with it. And this is basically showing what Houdini interface looked like when I'm working on it. And what I have to do for people like Chris Garazi is I have to create what I call digital, or what are called digital assets. And these digital assets can be very, very complex. And I'm showing in this picture that on the left, there's a decision. Do you want to mirror the simulation? Because frequently they only do half of the simulation because it takes so much supercomputing time to generate the data that they will then mirror it. So this is on the left is just the digital asset part that will allow them to mirror it. The middle section is some complexity, and you can have literally hundreds, if not thousands, of these little nodes. It's a graphical programming language. Inside of each of those nodes at the bottom level is either Python or C++, or what I program in is Vex, which is kind of their assembly language. It's faster. And then that's just a close-up on the right. And so when I'm done with all of that internal stuff that's difficult to generate, I generate an interface that's appropriate to the particular audience. So this is a specific interface I made for Chris Garazi, and although it's too small to read, that it's very simple. He can select what data he wants to visualize, and then he's got sliders and selectors for deciding whether he wants to mirror it and on what axis, and he can change the temperature range, colors, things like that. So it's specifically geared towards him doing that visualization, and it makes it easy for him to do a really cool thing. And this one, okay, let me go back. I thought it might have been a video. This is one that I did for him when I was creating the digital asset for him. And again, this is kind of cool because it's basically a copper plate with a certain pattern on it that's being hit at extremely high velocity in the back. And then that turns to plasma as it expands. And this is a cross-section animation of that same data set. In this case, only a quarter of it was simulated. And with the digital asset, he could mirror it left and right, up and down, and get the full thing. And this is another one that I've been showing you stuff on. And again, this is something that Chris can do himself. And this is an animation of that same data using a digital asset. So it takes him minutes to load in the data, set up his parameters, and then render this. And you'll notice that the logo down at the bottom, or the watermark for Houdini, that's because this is a free version of Houdini. So he did all of this on a free version of Houdini using digital asset. And one of the coolest things for me personally is by working at Sandia Labs, I just get to be involved in all different kinds of things. And I've just recently started working with Lawrence Livermore National Labs on their SCREAM data, which is the highest resolution atmospheric data that's ever been generated with a supercomputer. And also maybe a week and a half ago, 2 weeks ago, I was able to get a hold of this data set from Stefan Domino, and he's an expert on fire. And, you know, I don't know anything about fire, and now I'm starting to learn about fire. So this particular thing is called a pit fire. And there's all this math, like you see the papers that he writes, there's equations and all this stuff. And he generates really interesting visuals, but they're very, they're geared very much towards other people that are experts in fire. So I took his data and I didn't do the soot. I'm only visualizing the visible part of the flame, but this is an animation. And so I'm currently generating a separate animation with just the soot, and then I can combine those together so that I have the fire and the soot, and then I can add in streamlines showing velocity and turbulence and things like that. So for me, it's really fun. And the thing that's fascinating about this, I wish I had it in a loop, you'll notice that the bottom ring here, think of this as a pit with rocks around it, like out in the desert or something, and it pulses. And that's what this simulation is showing, is that these fires do pulse. And in another week or two, I'll probably know why. That's the fun part. Right now, I have no clue, but it's obvious. And that ball is a meter size, and it's just showing the light and this relative size. I prefer to have a person or a truck or something that gave you a better scale, but it was something I threw together just in time to make this talk. Okay, so basically I'm talking about you know, the idea that you can take commercial 3D software and supercomputer output and generate interesting, cool stuff. And this was the very first thing I did about 12, 13 years ago when they asked me if I could do anything with the data. And this was an aluminum ball hitting an aluminum block. And I did it in stereo, HD, gave them glasses so it would be in stereo. I had motion blur and all that kind of stuff. And so just to give you an idea of the difference, a normal scientific thing would be like the one on the right. I'm sorry, am I getting this wrong? Right, left? The one on the left, right? No. Anyway, the blocky one is a typical Paraview simulation of this can being crushed. And then Omniverse, which is in beta now, but an interesting thing, may make this easier, and it's much smoother, better rendered. And then my version of that is when I bring it in Houdini, I can tell it which areas to make realistic and which areas to color based on, in this case, velocity. So here's an animation of the Paraview version and my version. Okay, so I got through impactful visualization, and I still want to talk about the Carver Idea Lab. So as a visualization person, my director came by one day, and he had heard, I guess, that I was doing stuff with AR and VR and had done that for a long time. And he asked me if I could create a virtual reality lab. And I go, sure. So that was a Friday afternoon, just kind of impromptu. He walked by. Monday morning, I had funding for creating this lab. And the thing that's really fascinating about the Carver Idea Lab is that it's collaborative augmented reality and virtual reality. And I don't allow anything to be created that isn't visually interesting. And I don't allow anything to be created that isn't collaborative. And collaborative means that all different headsets can interact with each other, and every single application has what I call an observer mode. So any device that can connect to the Sandia network can be involved in a virtual experience. And how much time have I got? Do I have another 25 minutes?
Yes, you do.
Yes, you do. Yes. Good. Good, because I have 300 or 400 slides and I need to get through them all. I gave a talk once where I had one of 301 and they go, how much time I got? Oh, crap. Anyway, so those of you that don't quite understand the difference between augmented and virtual reality, I always start out by saying that I think virtual reality is very mature. It's very interesting. It's really good for training. But I don't think it's necessarily going to change our lives in the way like smartphones have and ATMs and fire in the wheel. But I do feel that augmented reality will fundamentally change the way we interact with the world and each other. So with that said, I've done mostly VR stuff because it is more mature. So this is an example of 4 people with AR headsets on. These are HoloLens 1 headsets. And one guy is talking about it and he's pointing at things, and the rest are seeing exactly what he's seeing. And as an observer, we're seeing this view. And also there's a guy with a little computer, a Surface, and he's seeing the same thing they're seeing. So he doesn't have to physically be in that room to interact. And that's the collaborative nature of it. And then this is VR. And in VR, he's seen something similar, and anybody else with a VR headset can see that same thing. And for me, it's really, really important that you can have multiple people collaborating on different devices. And I think I have time for a little side story, but in the early days when the HoloLens 1 first came out, I was able to go to the first developers conference as a special guest of Microsoft, and I got ferried around with a Microsoft badge and VIP and all that sort of stuff. And I came back and I was really, really excited. And I had a headset, but nobody else had a headset. So months go by and eventually people get headsets, they start writing applications, and they're very simple. And we have a meeting in a conference room, and my wife is there, who's an archaeologist and a scientist, and maybe 5 or 6 other people. And they were passing around this one HoloLens headset, and the guy would pass it to one person. They go, "Oh, interesting." Another next person, "Oh, interesting." It gets to my wife, and she goes, "Well, what's going on?" There's, there was nothing interesting at all. And so I took the headset, and there was nothing there. When the guy had moved the headset to the next person, something got messed up, and they were all looking at basically an interface, but basically the default interface for the HoloLens, which basically is a menu. So they're looking at a menu floating in space, and that was it. And I was like, okay, never again. I'm never, ever, I hate this where somebody puts on a VR headset and you say, "Do you see the red ball? Look to your left. Is there a red ball at your feet? Well, turn around behind you. Oh, there it is. It's behind me. It's a yellow ball. Oh, well, you want to see the red ball." And so when we started the Idea Lab, it was like I never wanted to be in that position where I was trying to talk somebody through it. So every single thing we've ever done, it's always multi-user and it's collaborative, and you always have an observer mode. So I can always have a computer. In fact, the next slide, I'll show you that. So on the picture on the left, that's the outside of the Idea Lab. That's kind of the lobby of the Idea Lab. And that's an older picture, but that screen on the right side, it's actually a touch table. I have a 55-inch 4K slanted, it's called a drafting table, touch table, and that's observer mode. And you can use your hands to navigate around inside of the virtual world, which is inside the room. So on the right side, you're seeing a screenshot from an iPad of an augmented reality robot that I textured. And it's just an empty room. But from the outside, either from a computer or an iPad or anything that can connect to the Sandia's network, and even if you use a VPN and connect to the Sandia network, any device can get into this mode where it's observer mode, or my wife likes to call it drone mode, because you kind of float around in there. And you do have a blockhead, and so people do know you're there and you can talk to them. And the cubes that we use in that left picture are kind of fun because you can program them to be different colors. So there's a green, orange, and purple headset. And I limited it to 3 in part because the room is 16 by 20 and I felt it would get crowded, but mainly because once we went wireless, we were limited to 3 headsets. And once you have a VR headset that's wireless, wires can be so painful. Anyway, here's an example of 2 screenshots from an iPad. One is a device called a B-Dot. Basically, it detects magnetic fields and it tells you what their strengths are. So it's just a CAD model that I have textured and put into the HoloLens 1 and displayed on, not the HoloLens, on the iPad. And so that's just a screenshot from an iPad, and you can move the iPad around and you can actually press a button on the iPad and it'll go to exploded mode so you can see what's inside. And the one on the left is just, if you just go to Apple's like AR gallery and if you have an iPad or an iPhone that's fairly modern, you just click on this model and place it somewhere. And so literally 5 minutes after this talk is over, or you could do it now while I'm talking, you could figure this out and you could have something that looks like that and the lighting matches and you move the thing around. It's really fabulous. And so just a quick thing about the equipment we have. When I first started it, I realized from many years of experience that even though I could have bought all the different kinds of headsets, I could have bought lots of different stuff and evaluated different things. What I did is I bought the Vive Pro, and that was it. I didn't get any AR headsets initially. I didn't get anything special. I wanted to develop applications, custom applications, and I didn't want to be bogged down with trying to figure out how to use lots of equipment. But over time, we got those gloves that are in the middle view. Those are kind of cool because they have like piezoelectric crystals on the tips of the fingers, and you can play music through them, which is not their intended use, but you can, and you feel the vibration of the music in your fingers. But typically, if you pick something up, I will just pick up something that's vibrating, you can play a square wave into the fingers and you'll feel that haptic feedback. And also it tracks your fingers in a very clever way. I don't particularly like gloves because they're all different sizes, they get sweaty and stuff. But there's this material that as it stretches, it changes its resistivity so that they can figure out where your fingers are. And before these were commonly available on the bottom right, the index controllers, I was a developer outside of Sandia and was able to get 2 sets of these as early betas, and they're really nice as well. And I was lucky enough to be invited to the Magic Leap Developers Conference, so that's independent of Sandia as well. And I got a headset and they're great, but you can't wear glasses with them, which makes it kind of hard if you're going to share things. And so we have a lot of interesting stuff, and I got a clean box which uses ultraviolet rays to disinfect things. So it's really fun that I get to play with all this cool stuff. And besides the fact that everything has to be collaborative, it has to be observer, you have to allow people in all different devices to be involved. I wanted to use the skills that I had developed doing visual effects for movies in virtual reality and augmented reality. And it turned out that it was a lot harder than I thought it would be, because in movies, when you texture things and you create effects, it could take an hour per frame to render. It doesn't matter how long it takes because you just render the frame and eventually you put them together, composite it with the film, and then you're done. But in virtual reality and augmented reality, it has to be real time. But I still wanted to have things be as realistic as possible. So it was a big deal to me to learn how to use 3D Coat and Substance Painter, which are 2 3D painting programs, along with Unity, and initially Unity, to create visuals that were more accurate. And this is an example of using Substance Painter. And this is a very simple object that you could put, 5 or 6 or 10 or 20 of them into a virtual environment and walk around. And it looks very simple. But once you start painting it, it's still just as simple. It hasn't gotten any more complex, but you're adding levels that make it seem complex and make it seem more real. So the combination of texturing these objects and lighting them allows you to create stuff that looks incredibly real. And I never have a lot of time to play games, but you see games that it's just breathtaking what they do. But in technical stuff, that's not common. It's very uncommon to see stuff that is as detailed as that lantern in a technical thing. In fact, I think it's very rare. I'm not the only person doing it, but I think it's pretty rare. So here's an example that I like to show, because there's like 300 polygons in this object, or maybe more, but very few polygons. And so I wanted in this high bay scene that we created at Sandia, I wanted to have a lot of detail and a lot of objects. And so I had intercoms and I had these speakers, but I wanted them to be small enough that they wouldn't impact the playback rate of the VR headsets, because I tend to get sick easily. So I want to make sure that the VR is playing back really fast. So this is what it looks like in VR after I've textured it. And in fact, I put in a little Carver logo there. Made in the USA. I don't know how clear that is on your screens, but the thing it maybe is a little bit interesting here is that if you look at them together, that down in the right corner, you can actually see the segment of the horn, or the rim of the horn. You see a little jaggy thing there, but you can't see it at all in the center. It all just looks perfect and nice. And that's all based on texturing. And so I hired every summer I would have an intern, typically a high school intern, who was a computer science or a math major. And a couple of years ago, I decided that I would have an artist instead. So we got in an intern who had a Bachelor of Arts degree, I think from the University of Maryland. And I taught him how to do this substance painter stuff. He taught himself how to do Unity, and he was already an expert at Blender. And it was great because he has been incredibly good at creating this kinds of things. And unfortunately, there's a lag time between when I do stuff and when I can show it. So a lot of this stuff is fairly old. And then this is a really cool demo that an engineer at Sandia Labs, or a member of the technical staff did, Tim Shedd. And there's a bunch of fun things about this particular image. It's basically showing all of the flights that are over Georgia in a 24-hour period of time. And everything is accurate. The sun is accurate, the time is accurate, all the trails are accurate. We could have them on the ground. We obviously have the trails, the contrails of the aircraft elevated at eye level so you can walk through them and look at them. But there's a couple of things that are interesting for me on this demo. Is we used to have walls. If you notice, there's no walls. There's a floor and there's a door. If you want to exit the game, you exit the virtual door and the game ends. But we used to have people walking into the walls, and I could never understand it because there's a wall there. Don't walk into it. And you get a warning when you get close to the wall. And we'd have people hitting the walls really hard with the controllers. And it's not a game. I mean, you're walking around, you can move through time and you can fast forward and rewind, and you can look at the trails, and there's color coding to tell you whether they're ascending or descending and how fast they're going, all kinds of things. But why are you walking into walls? Why are you hitting the walls? So I got this idea. I didn't read about it in any blog or research paper, but I got rid of the walls and I put a ground about 50 feet below the ground that represents the Idea Lab. So that ground that you're seeing there is the size of the Idea Lab, minus maybe a foot. And so people will go over to the edge of it and they'll look down and they'll see a long drop and they'll scurry away from the edge. In fact, it's been so effective that nobody has hit a wall since we stopped using walls in our VR, and we just have imminent death. So if you get within a foot of the physical wall and look over the edge of the ground, that your virtual ground, you will see a long fall to your death. And so people stay away from the walls now. Just a kind of interesting side thing. And I can't show you this whole thing because there's parts of this that have some OUO rocket stuff in the center of this high bay. But if you notice, if you look around, you'll see those intercoms on the wall just past all the tool chests and stuff like that. And there's a lathe and a milling machine down the right, and you can teleport up these stairs and walk along these walkways. And there's also a place where you can teleport way up to the top of the high bay, where you're up near the lights. And once you're up there, if you're afraid of heights, you start sweating and get really nervous because you're like 50 feet above the ground looking down. And in the hundreds, like at least 300-400 people that have done that demo, only a few have been able to walk off of the virtual ledge that's 50 feet up. And I find that interesting. I have trouble doing it. I know the ground is there, but you're so immersed in it and it feels so real that to step off of a 50-foot ledge, even though it's virtual, and you'll just be floating in the air. Unless, of course, we write the software that we detect where you are and you actually start screaming down towards the ground, which would be really immersive. So that's about it. I can talk a lot in the questions and answers about VR and headsets, and I'm going to talk a little bit about the latest, greatest headset because I thought this audience would be interested. This is one last thing I just wanted to bring up is that if you are interested in VR and you do have a VR headset, Paraview is free. This is a free data set of a cross-section of aluminum can being crushed. And you can view this in VR. And so if you have an interest in that kind of stuff, I'd definitely go check out Paraview. And the VR is actively being developed by Ken Martin, and it changes every month. So it could be interesting. Okay, now we're going to get to something that most of you probably heard of, the Oculus Quest 2. Now, this is kind of amazing. I have the Vive Pro eyes, which are the ones that do eye tracking. And this I have at home. I'll explain why I don't have them at Sandia yet, but I have this at home. And the quality of the images is much better than the Vive Pro. Of course, the Vive Pro is like 3 years old now, so in fairness. But the screen door is basically gone. So there are much better headsets out now. There's ones that are higher resolution, but this crossed a barrier that said it's high enough resolution that you're not seeing this like pixely. Like screen door means you have kind of lines between the pixels. Now, in fairness, your mind gets rid of the screen door fairly quickly when you're in VR. So it's not as big a deal as a lot of people make it seem. Once you're immersed in the VR, your mind starts believing everything. So the quality is not important in some cases. But if you're trying to see details in something, then it becomes important. This particular headset has gotten a lot of bad press because it has to be connected to your Facebook account. And if you create a fake Facebook account, their AI will figure it out and apparently disable your headset. But it is amazing headset. It gets rid of that screen door. It's $299 and it works. And the thing that makes it really interesting is that it covers a lot of ground. It can be a standalone headset. You just take it with you anywhere and put it on. You don't even need the controllers because it'll work with your hands. But it's got reduced functionality. It'll probably go 72, possibly 90 frames per second standalone. But you can also connect it wirelessly or through a wire to a computer, and then it can go up to 90 hertz or even 120 hertz. It can run software that was reserved for higher quality headsets like the Oculus Rift. It can run all of the Steam software. It's absolutely wonderful for $299. And like I said, I don't have a lot of time for games, but here's a screenshot of one of the games that I have been playing with. And here's another screenshot, same thing. Now, this is exactly what you see in the headset, but screenshots don't have any of that screen door effect. They're just totally homogeneous and smooth. So doesn't look quite this good, but in terms of resolution and color, this is exactly what it looks like. And this is a short video just to show you what it's like. And
You
this is
really need to hit
standalone
those
mode.
bypass switches right over there. All right, hyperdrive controls are active. Make the jump to light speed.
So the point is that that's standalone. You can get higher resolution, better frame rates with a cable or with Wi-Fi. Now they claim that the Wi-Fi is just as good as the cable. I have a very sophisticated G5, wireless G5 router and all that, and I don't get the same exact performance as I do with the cable. And so for what it's worth, and that's a sample project that I created with, I probably came with the software, I've forgotten now. But when I became a developer on the Quest 2, I think that was one of their things. And the idea here is it's a screenshot and you can read everything really clearly. And obviously in this podcast, you can't see how clear it is, but all that text, even in the very background in the VR, it's really easy to read. And this is a screenshot from a game and it's just phenomenal. All that detail is in the game. It does work. It's real time, you know, it's smooth and pretty amazing. And then it can also run Rift applications using either wireless connection or the cable, the link cable, and also can run Steam VR applications. This is one of my first immersive experiences from Steam, which was you see a blue whale underwater, and it's a great first experience for people because there's great sound, great video, and it's somewhat surprising. And then this is a little bit about the link cable. They charge a lot of money for their link cable. I did buy an inexpensive one. It didn't work as well. And so I just went and bought the full-blown one and it works great. This is really something great. If you're looking to get into VR, a Quest 2 for $299. The only difference is the $399 has more memory. And there are some games that won't even fit on the headset as a standalone game. It's really about how many games you can get on the headset for standalone mode. And, you know, I'm not a big gamer, so I didn't get the more expensive one, although I bought one for my daughter and I did get her the bigger one. So at Sandia Labs, this is of no interest because Facebook accounts and not secure. There's all kinds of reasons you wouldn't want to use these at Sandia Labs. But it turns out they have a business edition. And the business edition, these are their slides, so to speak. So I'm not going to read from slides and stuff. But basically, you get software that you run on your server. And when people put their headsets on, if there's new software or things to download or updates, it'll all be visible to them. They can't load in games. They can't load in anything outside of your organization. And so it makes it secure, encrypted, and all that stuff. I ordered 6 of them, but I'm having some trouble with the agreement they want me to sign on behalf of Sandia Labs. So that's going through legal. But I think for people to have VR meetings, this is a really, really good choice. Now, Vive just came out with a new Vive Pro 2, which will be awesome, but the wireless connector to that limits its performance dramatically. And they also have their, what's that other one called? But they have their standalone one, which is similar to this one, very, very much, very close. And I could talk about the differences if you're interested. And so last slide is, you know, cool digital assets, lighting, shadings. And this is a slide is typically meant for people that are scientists and stuff like that. So I'll address it to you, the audience, as students, but also as future scientists and engineers and and anybody that presents stuff. If you want to get some advice or ask me questions or stuff, you can contact me at that address. And if you don't remember to do that, Diane knows all of my contact information. And any questions?
Well, thank you so much, Brad. Yes, we'll now leave some time to address your questions while waiting for those. You've almost convinced me to go out and invest in a VR headset, but the issue I've typically had with those is motion sickness. Has the new one addressed those issues to any extent, or do you still have issues with that?
So yes and no. So there are two people in my group, myself and Pat Crosneau, that tend to get motion sickness from VR. And we discovered that both of us got car sick as kids. I got car sick very easily.
Yeah.
And so this is a big problem. And when it first came out, all the games were 75 or 72 hertz.
Mm-hmm.
I think I've gotten a little bit acclimatized to it because I was able to do it, but it just makes me uncomfortable. Not sick, but just I can't do it for long. So if you got one of those headsets, I'd recommend you get a friend to get one so you can try it.
Right.
But try to make sure that you're only doing stuff at 90 hertz. And they don't do anything specific to help you, but the different experiences will have a comfort range. So they understand that some people can handle, like the first time I put on an Oculus headset was at a gaming company, and they said, here, try this. And I put it on, and it was a roller coaster. And I took it off within 5 seconds, and I was sick for a long time. In fact, my daughter, myself, and my wife went to see Blair Witch. That's the one with the handheld camera.
Yeah, that makes me sick in 2D. So
yeah, so I saw it in 2D in a theater, and after a few minutes, I walked out. I laid down on the ground outside the theater, and I waited for them to come out, like an hour, and then my wife had to drive home, and I was sick for hours.
Yeah,
I think I wasn't really quite well till the next day. So this is definitely an issue. Certain things at 90 hertz are not going to bother you. Certain things at 120 hertz are not going to bother you. But there'll be stuff that will make you sick.
Yeah. I'd heard higher refresh rates and the resolution were the two biggest issues with
I would actually say
sickness.
the biggest issue is what the content is. Because if it's a white wall that's not moving, you're not going to get sick. You know, so content, like I say, when you buy stuff, they will rate them, you know, I don't know exactly how. It's probably motion, comfort, easy, hard, and super hard or something. It is definitely a concern, but I will say that this headset, in terms of price and clarity, it's the first one that I've recommended.
Yeah, I've been waiting for a version of VR which I felt was adequate for decades, and it feels like it's almost here.
Yeah, you know, this industry is changing very fast.
Yeah.
A friend of mine created a headset years ago that used a Samsung phone, and it could be AR or VR. You just lifted off a lever at the front, and now it was AR, and you put it down, it was VR. And maybe that's the way things eventually will go. I always thought that Apple would come out with glasses that connected to their phone, and the phone would be the processing.
Yeah,
but
well, they're probably
G5,
working on that.
Well, I'm sure they are, but maybe G5 and the power in the glasses will be enough, and maybe they'll have AR, VR in the same thing. There's so many things that can be done, and it's not obvious. It's like personal computers. Whoever thought that would work? But that was a silly idea. I always used to talk about application-specific computing, where you would have a computer and it would connect to the internet. Of course, the internet didn't exist then, but it would connect to a network and it would only do one thing at a time. So it would be a word processor, or it would be a spreadsheet, or it would be a game, but it wouldn't need a fan. it wouldn't need you to do anything because you'd just be using an application and it would just be loaded on, and it would be simple. It wouldn't have to have a lot of memory and on and on and on. The idea that my mom would suddenly get a personal computer and need to be the admin on it was crazy. And of course it didn't work, but we still have them.
Right. I was interested that you said that you felt that AR was going to be a game changer rather than VR. Can you expand a little bit on that?
So you have glasses on.
Yeah.
I have reading glasses or computer glasses. In the future, everybody will have glasses and their worlds will be augmented. And you won't be able to tell the difference between what's real and not real unless you like tap the side of your glasses and all the augmented stuff disappears. The potential for being able to augment your world with technology is tremendous. In fact, I always felt that the reason Magic Leap got billions and billions of dollars of investing is they weren't working on, and I have no inside information, but this is my opinion, that they weren't working on an AR headset. They were working on an operating system for your life. So that from when you woke up in the morning to when you went to bed at night, your life would be controlled by this operating system. And they felt, again, this is just me, but they felt that it was important for them to do that rather than Apple or Microsoft, because they were good guys and they would make sure this operating system for your life would not be benevolent or not be malevolent. And that was the reason why they would only partner with companies that did open source and all these kinds of things, because ultimately everything that goes into your brain, in my opinion, will come through your glasses. You won't have a television. Why would you have a television when you could have an augmented television that could be any size and be in any location? So, I mean, I could go into a lot of details about the way it'll change things. And I'll just use one example I came up with many years ago. So with the HoloLens, one, it was clunky, it was heavy, it wasn't that great. You know, the battery didn't last long. But if you had a bunch of them in a hospital in a level room, and you had a code, whatever it is, when you run to the room, and you just grabbed one of these headsets and it recognized who you were, it recognized the room. When you walked into the room, instantly all the information that was important would immediately be shown to you in a way where you couldn't ignore it. And like the casters on the bed, you could look down and if they were locked, they would be red. And then you could either do a hand command or a voice command and say unlock casters, and then they would all turn green. And now you can move the bed. There's just I could come up with 20 or 30 things that would have worked 5 years ago with AR that would have completely changed the way that the emergency people dealt with a patient that was having issues in a patient room. And I mean, you take almost any situation that you can come up with, like forensic science when they go to a crime scene, any one of those things, make up one. I can come up with ways that AR would fundamentally change that. And, you know, I could give another talk. If people want to hang around for a couple hours, I could talk about how that could change things. But I really do believe, I don't know when it'll happen, and I don't know who will do it. Apple's obviously interested in AR and they have no interest in VR. They've never done anything in VR, but they've spent billions of dollars buying AR companies, either to keep them away from other people or keep them from developing competing technology or whatever. So they clearly are working very, very hard on creating AR. And I believe Apple has a vision like I do, that they believe that AR will fundamentally change everything we do and how we do it.
Right. If I can back up to the earlier part of your talk where you were talking about impactful visualizations. In data science, when you talk about visualizations, you're typically talking about 2D. They'll occasionally go 3D if they need another dimension, or they're just turning basically a 2D display into a 3D display. Have you given any thoughts to how using animation or 3D could be applied by a data scientist to make a more impactful display?
Well, first of all, 3D, I was a big fan of that. And I have I think it's a 90-inch 3D Samsung monitor actually in the Idea Lab. It's the only thing physically there besides the walls and floor. And I really liked it, but it never really caught on. And now it's really hard to even find a 3D TV. I don't know if they make them anymore. So 3D feels like, even though it was valuable. In the case of that aluminum splash, when I had motion blur on those things and I had it in 3D, you could see things that you can't see in a 2D display. And VR, well, there's some new technology that came out recently called Nanite from Unreal Engine that may change this, but VR typically is very limited in the amount of geometry or the complexity. So that's not necessarily a 3D thing. So 2D visualizations, most of what I would do in impactful visualization will be 2D. And the real thing about what I call impactful visualizations is that there may be 4 or 5 different distinct groups of people that you want to show your research to. And those may be static images, maybe a video in presentation.
You're breaking up your audio.
What's that?
Your audio is breaking up. Maybe stop sharing your audio in the image. Maybe that's. Or just stop sharing screen. Maybe that'll work.
Yeah.
Yep. I can hear you now. That worked.
Yeah, and so when I think of that, I think if you have the capability of generating a variety of different data visualizations, we'll call it, then depending on your audience, you might choose to do something different. And in most of my cases, it's going to be like that fire thing. That's a 2D animation. I'm not going to be doing that in VR. I'm not going to do it in 3D. I could do it in 3D, but I may have one of the only 3D TVs or monitors left in the building I'm in. They've all been replaced with more modern, once we went to 4K monitors, I don't know if there were any of those were 3D. My 3D monitor is 8K, by the way.
Oh, okay. Yeah. Well, I was thinking more 3D on a flat screen, not real 3D. So that was.
Well, I meant 3D. Oh, are you talking about wearing glasses so it's 3D? Or
both the wearing of glasses and the use of displaying more dimensions in the displays rather than having like a bar chart, scatter diagrams, network diagrams, and those types of things. Can you display or use the concept of more dimensions or animation to?
Right. I was taking it literally to think that you would have 3D glasses on.
Well, that would be optimum.
Yeah, I work in a visualization group, and we have lots of experts on all of that in terms of things like color maps and 2D and like if I were to tell them I wanted to do some kind of scatter plot or a bar graph, but do it in 3D, not 3D with glasses, but just dimensionally, they would just cringe and go, no, don't do that.
Yeah.
But that's the kind of thing you're talking about. And not my area.
Well, not necessarily just reproducing what they're currently doing, but displaying something that's kind of more it's less tangible or more abstract concepts and using more imagery or animation.
Well, like I say, there are people in our group that are experts at that. My background, because I went from being an electrical engineer to doing visual effects for movies to then applying what I'd learned doing visual effects to scientific data. My main focus is taking those extremely complex simulation data sets, sometimes terabytes of data, and then trying to make them look anywhere from diagrammatic to cinematic. And that's my focus. In terms of the stuff you're talking about, we have somebody listening who's an expert at that. At least I think she's listening, Pat Crosno. But we have a lot of people in our group that they have doctorates and they know that stuff, and I don't. So I'm not the right person to ask.
Oh, well, thank you so much, Brad. Well, thank you for, I think we're just about out of time. So thank you for spending time
Why
with
do you
us and
think
sharing
it's
your knowledge.
4 hours?
Oh, I could talk for 4 hours, but I think our audience would leave.
Well, I only see the 4 of you, so I don't care about the rest of them.
Yeah, Pat's in the audience. You just confirm that. So thank you so much for spending time with us. And I want to thank members of our audience for joining us today. And I hope to see some of you in some of our future presentations. So have a great afternoon and a great weekend. Thank you so much.
Okay, nice seeing you.
Thank you,
Bye.
Brad.
Thank you, Brad.
Brad.
Thank you.
Okay, I'm leaving.
All right, bye.
Bye bye.
Bye.
We now continue.